Greetings, my name is Jorge Kauachi, and welcome to another lecture of the 2020 Honors Chemistry Short Lecture Series. Let me ask you a question. Have you ever broken your phone screen? Or maybe a pebble has hit your car window in the highway, and it bothers you so much that every time you're gonna use your phone or your car, you're gonna see that imperfection. And you need to fix it because if not, it could spread. Well, what if I tell you that that could be fixed in a few years? In this video, I will get you familiar with the glass that is being worked on by researchers as we speak, that has found a way to be bendable so that it doesn't shatter. It's called alumina glass. In order to talk about the new type of glass, we need to be familiar with the multifarious types of glass that already exists. I will then get into the new type of glass, its properties, and its significance. Lastly, I will talk about how to apply this new alumina glass, its utilization, its necessity, and where it can be made. The inspiring CNN article describes alumina glass as a more durable and ductile material, better suited for commercial applications, made by other types of glass that often shatter. The alumina glass that the article expanded on would replace the objects made of silica that most glass is made of. It's an amorphous solid with a very brittle atomic structure. This is due to the stiffness of the molecular makeup and that phase that the atoms cannot displace energy by forming bonds in neighboring molecules. If this new type of glass would be released to the public, it would be mainly used for commercial use, due to its ability to eradicate certain concern over the durability of glass and the lack thereof. For example, people who use phone screens, windshields, and optical wear would be safe from the constant fear of damaging their possessions. This image depicts the making of the alumina glass. The alumina will be hit with an intense laser, which will turn the plasma glass into a colorish purple color when heated. When the cooling process takes place, the newly discovered glass will shape and form the glassy solid. Let's move on to our first main topic on the 8 types of glass and their importance. Each glass will vary their information because they all have very different variety of structure that other glass may vary from. Our first type of glass we would be discussing about is soda lime glass. Soda lime glass is the most commonly used glass. It's used 90% of the time. Another common name for it is soft glass because it's extremely brittle, meaning it shatters. And because when it's made by the heating of the combined substances, it has a smooth, soft texture. As we see in the pie chart, we know it's mainly made from silicon dioxide, sodium oxide, calcium oxide, and other mixed instant substances. Because its chemical structure is so stressed, meaning that the atoms are compact, any movement of the molecules will cause the glass to shatter. Now let's move on to potash glass. Potash glass is called hard glass because it passes from the molten substance to the rigid state more quickly. It is therefore more difficult to manipulate into elaborate forms. Potash glass is a composite of soda lime glass, but the word potash means potassium carbonate, which comes from wood ashes. It's much stronger than soda glass and used for putting the glass in situations where the process of heating is involved, as it has a good tolerance for thermal difference. Next, we have optical glass. Optical glass focuses on the creation of course, glasses. To make glasses, you will need crown glass and flint glass. When you look at glasses, you see that the lens is kind of curved out as well as curved in. This is what crown glass and flint glass mean. Crown glass causes the curved out part of the lens, and the flint glass focuses on the inward part of the lens. This will cause an achromatic doublet, as you see in the diagram. What happens is that achromatic lenses are corrected to bring two wavelengths, which is the colored part of the diagram, into focus on the same place, where it is where they cross each other. The chemical composition of optical glass is the same as soda lime silica glass, but it involves lead oxide. Optical glass is as brittle as soda lime glass. Next, we have Pyrex glass. It's called Pyrex glass because when they discovered another type of glass that wasn't made before, the people who discovered it trademarked it as Pyrex. Why the word Pyrex? Because it derives from the word pie, which is what it was originally used for. Originally, Pyrex glass was used for laboratory laboratory glassware, but mainly for kitchenware. Now we know that it's mainly used for carrying corrosive liquids. So, then what is the name of this actual glass? Well, it's actually called borosilicate glass. It's made out of silicon dioxide, boron trioxide, aluminum oxide, potassium oxide, and sodium oxide, as shown on the pie chart. By having low coefficients of thermal expansion, this means that it will be heat resistant. Next, we have safety glass. One sheet of safety glass includes 3 sheets of soda glass, another 3 sheets of soda glass, and a polyvinyl isobutyl, a plastic that merges them together through the heating of glass. It isn't limited to 3 sheets of glass. Depending on where the glass will be used, more sheets of glass will be involved. It's known that this type of glass can be broken into smaller pieces. So, a passenger plane window is about 1 centimeter and would experience an excess of 1 metric ton of force. 1 centimeter is approximately from the middle knuckle to the tip of your nail. Next, we have photochromatic glass. Photochromatic glass is used for thinning the light that goes through it. This occurs because the potash alumina being modified with lithium sulfate with a crucial dash of silver. This is common in optical glass that shade the sun. In the diagram, we see what happens when light hits the photochromatic lens. The opening and closing of this diagram is called dithienolithianese. Commonly known as crystals, lead crystal glass is used for fancy tableware. Lead is in crystal glass. It's actually 24% part of the glass. If it does come in contact with any acidic liquids, it will leach into your drink over time, especially liquor or wine, due to its acidic natures. That's why it's not often used, with the exception of special events, because lead could kill you if it is in your drink, but it's highly unusual for that to happen. Finally, we have colored glass. Colored glass, also referred to as stained glass, varies in color depending on its different metallic salts. It is used primarily for decoration. If copper is added, you will get a dark red color. If you add gold, you get ruby red glass. If you add silver, you get colors from red to yellow depending on how much you add. For cobalt, you will get a bright blue. When you add manganese dioxide, you will get a green color. If you add iron to oxide, you will get a variety from blue to green. And finally, chromium will give me a dark green. All of these different metallic salts are added to the soda lime silica glass. Our next topic we will focus on is the new type of glass. Let's talk alumina glass. We're discussing the information that is out there about this newly discovered ductile glass, from its atomic structure to its characteristics. So, let's get to it. Talking about properties of these newly developed glass, first we need to discuss what it's made out of. My CNN article says it contains alumina, usually called aluminum oxide, which is critical to this newly developed glass because the substance of alumina gives it its ductility. We see from the diagram and the second bullet point that it contains aluminum and oxygen. In the diagram, we see that the molecules and atoms are not very stressed due to the oxygen atoms giving their space to move around, making it bendy. The red dots are the oxygen atoms and the green are the aluminum atoms. One of its biggest challenges with this new glass would be on how to make glasses with this material because they would have to mix the alumina glass with the optical glass. And since it's still in its testing phase, we don't have enough information to see what the results or any side effects it would have. But it's still predicted by Erika Franksberg, head material scientist, that in a few years to come it will be released for commercial use. We move on now to the characteristics to determine the difference it has on the existing glass. Moving on to the characteristics, we see first on the list its high thermal conductivity. Having a high thermal conductivity means that it will resist drastic change to temperature if it were to be in that type of situation. We also see that it has a resistance to corrosion or abrasion, meaning that in a long time, erosion would not have changed anything about this glass material. Also being resistant to forms of chemical attack, that means that it can withstand many different types of chemicals being used. Now we move on to our last topic, where this glass can be used for. Still focusing only on the alumina glass, we will talk about where the glass could be used, why we would actually need it, and where it's made. This alumina glass would solve a large problem in the world and could be found replacing daily items. This desired item would include shatterproof screens, car windows, windows in general, and other items that would be better off as shatterproof. The importance of this product stems from that need to prove past ideas that describe how impossible this is to be wrong. The scientists that discovered this new glass were striving to find a solution to the common and tedious problem of breaking glass. Considering how new the glass is, it is still well into the testing phase before being put to commercial use. Thus, it can only be made in a laboratory. Here are all my works cited pages I used for my presentation today, and I thank you for actually listening to all this information about this newly developed alumina glass and its components. Hope you all have a wonderful rest of your day and hope to be prepared to answer your questions on the 21st of May.